We're on page 31, and we're going to do problem 10A, problem 12, and problem 14. So 10A. Here, let's read the problem. Find the equation of the line that is the right bisector, and the definition of the right bisector is perpendicular to and through the midpoint of the line segment between -3,6 and 5,2. So what this really means is, first of all, we're going to connect the points -3, 6 and 5,2. So if this is roughly the point -3, 6, and this point here is roughly the point 5,2, we're going to connect that. So the end of this point is represented in X, end of this one also with an X. And what we're going to do is, this is the right bisector, which means that it cuts this line here, the line segment, in half and makes a right angle when it cuts it. So this represents the midpoint right here, such that the distance from here to the midpoint is the same as the midpoint to here. So we represent the midpoint is right here, and the line we're looking for is this one right here. So a double-headed arrow just showing you. So this gives you a visualization, and it's quite often important to visualize what the problem is that you're doing. So you're connecting these 2 points, you're finding the midpoint, and then you're drawing a line that cuts the line segment in half with an angle of 90 degrees, which means it's perpendicular to. So we are looking for the equation of the right bisector, which is the black line with the arrows on the end. The right bisector forms an angle of 90 degrees, which means it's perpendicular with the line connecting -3,6 and 5,2. So in order to do this, there are 4 steps to solve this problem. First, we find the midpoint between here and here. So here you can see that we've set up X sub m and Y sub n represent the midpoint between this and this. And this is X1, Y1, and this is X2, Y2. So we sum the X's for the midpoint, -3 and 5, and divide by 2. -3 and 5 gives us 2. 2 divided by 2 gives us 1. We sum the Y's, 6 and 2 gives us 8. Divide by 2 gives us 4. So this midpoint right here is 1, 4. There's the midpoint right there. So the first thing is that we find the midpoint. Now we find the slope of the line joining the 2 given points that we were given in the problem. And the slope is y2 minus y1 over x2 minus x1. So we say 2 minus 6 is the difference in the y's, and 5 minus 3 is the difference in the x's. So we get minus 4 over 8, minus 4h, which really reduces to minus a half. So we now know that the slope of this line is minus a half. We just calculated it. Now we need the slope of the perpendicular line. That's part number 3. So we know this, the 2 of these hit each other at 90 degrees, so it's the right angle between the 2. So the product of their slopes, M1, M2, is -1. Or what we can just do is just take this one here, minus a half, turn it upside down, and change the sign. So turn minus a half upside down and change the sign. So the slope of this line Now, the new line we are looking for is 2. Slope of this line is minus 1/2. This is perpendicular to it, so we just take the negative reciprocal. You could use M1, M2 if you wanted to get that. So now we know that the line we're looking for has a slope 2, and we know it goes through the midpoint, 1, 4. So now we can use the slope point formula, and here now my y1 is 4, so I put 4 in here. My x1 is 1, so I substitute 1 over here, and the slope is 2. And when I simplify this, I get on the right side 2x minus 2, but the minus 4 comes over and becomes plus 4. So plus 4 and minus 2 becomes plus 2. So that gives us the equation of this line here, y equals 2x plus 2. So to recapitulate on this one, we determine the midpoint first of all, then which is right here. Then we determine the slope of this line. If this is perpendicular to it, hits it at 90 degrees, we therefore know the slope of this line. This line goes through the midpoint, so we can use the point slope form, which we do here to get the formula of the line. Number 12 on page 31, we're going to relate the units of demand Y for a product as it relates to the price. So Y, the demand here, equals minus 2.5x plus 300. First thing I just write down here over here is demand and price. So the demand is related to the price through this formula. Let's read the first part, A. Accordingly, how many units of demand would a price of 20 per unit generate? So we're given X equals 20 here. You got to substitute it into this formula and determine what Y is. So Y equals minus 2.5x, which is 20, because we're given that right here. Okay. And plus 300. Minus 2.5 times 20 is minus 50, plus 300 gives us $250. So we now know that if the price of a unit was $20, it would generate 250 units of demand. In the second part of the problem, what price per unit? Price is X, so we're asked for X. What price per unit would generate 200 units of demand? So now we're given Y. We substitute that over here, right here. 200 equals minus 2.5x plus 300 and solve for X. And that's what I did right over here. I just substituted Y equals 200 into the equation, and now what we need to do is solve for X. So we take the minus 2.5x and bring it to the left side so it becomes positive. We take the 200 from the left and put it on the right, and it becomes negative, and the 300 stays on the right. So 300 minus 200 is 100. 2.5x equals 100. If we take the 2.5x and divide by 2.5 in order to get x, we have to divide the 100 by 2.5, which means that this would give a price of $40 per unit. So go to the next problem, number 14 on page 31. This is kind of an interesting problem because you can, in a sense, visualize, take the equation and in your mind sort of understand, because it's really a business formula. It's kind of a formula, although it's very simplified, and I'll explain why. So here, imagine that you went into a showroom for a boat and you spent $75,000 on it, and you'd want to know how much, it went down each year. Well, according to this formula, this particular boat would go down by $7,777 for each year from the year of purchase. So if you started $75,000 after 1 year, it would be worth less by $7,777. After 2 years, you would multiply this number here by 2, and then you would subtract it from the 75,000. If it was 3 years, you'd multiply this number by 3, etc., etc. So it gives you an idea of when people talk about depreciation. Now, generally, things don't depreciate linearly. In other words, they don't depreciate by a fixed amount each year. When you come to talk about cars or boats, they generally depreciate more in the first few years and then depreciate less in the older the car or boat forms. But anyway, this is still an interesting problem. And the first part of the problem was, given this formula here, what was the purchase value of the boat? Well, the purchase value of the boat is obtained by realizing that the years from purchase is 0, because you just purchase it, you haven't used it, so x is 0. So you replace the x with the 0. So x equals 0 for a new boat. You substitute that in here. This should be a 0 here. If you put in a 0 here, and of course this term becomes 0. So the boat is worth $75,000. What was the purchase value of the boat? After 5 years means that you're going to replace the x with the 5 here, because x represents the years from the purchase. So all you have to do is take this formula, replace the x with a 5, and you can see after 5 years the value of the boat has gone down by $38,885. So after 5 years, the boat is only worth $36,115 according to this calculation, because you take the $75,000 and you multiply this by 5, and you come out with what they sometimes call is the depreciated value. So both A and B involve substituting values for x. In this one, we substituted a value of x of 0. Here we substitute a value of x for 5. Now, the third part, let's read what it says. How many years, so you want to know x, would depreciate the value to 0. So you want y to be 0 now. So you go back into this formula, and you put, instead of y, you put 0 equals minus 777x plus 75,000, and then you just solve for x. How long x would it take for y to equal 0? And you bring this from the right side to the left side, and you solve for x, which means you divide this by 7,777, and you divide this by 7,777, and you get 9.65 years. So what this would mean is that if the boat depreciated by $7,777 each year, eventually at some point the boat would have no value. And that's what you're calculating. When y is 0, what would x be? Now, as I said, this is not a typical kind of a problem because most items like boats and cars don't depreciate linearly. For example, if you bought a new car for $20,000, let's say, and you took it back the next day to the dealer, he might take off 25 or 30% from in just for a short period of time if he repurchased it from you. On the other hand, if you had a car that was 8 years old, and let's say you bought it new at 20 and it was down at 8,000, after 1 year, it was still okay and still running. You might only lose $1,000 or $2,000, so which wouldn't be that huge amount that it would be when you originally had the car and let's say wanted to sell it after a year or that. Now we're on page 32, and the problems we're going to do are 16 and 19. So if 100 posters cost $9 and 500 posters cost $15, then express the cost y in a linear equation with the number of posters x. So what we want is an equation that gives us y in terms of x. So what you can do, you see when you're given this here, 100 posters cost $9. Your cost is your y because you want to express the cost y. So this, we could write this as an ordered pair, 100 being the number and 9 being the cost. Here it's the number printed and the cost. So the x is always the number of posters and the y is the cost in dollars. And how do we know that? You say, well, why don't you reverse the x and y? Because we're told over here that the cost is y and the number of posters is x. So we set these two up as an ordered pair and we set these two up as an ordered pair. Why do we do that? Because then we can get the slope of the line. So this is x1, y1. This is x2, y2. And you can see that m is the difference in y, 15 minus 9 over 500 minus 100. So we get 6 over 400. This equals 0.015. So we know the slope. We can use the point slope equation and say y minus 9, if we use this as our y1, equals mx minus x1, and that's 100. Now it doesn't matter which ordered pair that we use. We could use the other ordered pair. We still come out with the same answer. Anyway, this gives us the equation, point slope form, and here for m we substituted 0.015. So we've come out with the equation, express the cost y in a linear equation with a number of posters x. So here's the cost y in terms of x. What would 1,000 posters cost? So the question here is, if x were the number of posters and equaled 1,000, what would y be? So we go back to the equation that we have generated right over here in part B, and we want to know the cost when the x is 1,000. So we put the x equal to 1,000 into this equation. We work it out. We transpose the 9 from the left to the right. And here we have 1,000 minus 100, which is 900. 900 times 0.15 is 13.5. We add it to the 9, and we get the cost being 22.5. Now, as I said over here, instead of using the this ordered pair to generate the equation, this one over here, I'm going to use this one in this case. I'm going to use the same slope, but I'm going to substitute 515 just to see what happens. So, substitute 515 into this equation, y minus 15, because my y1 is 15. My slope is still 0.15, x minus 500, because there's my x1. Now, this equation here is really the same as this equation here. They'll both give us the same value. Let's check it. So we use this equation. The cost of 1,000 posters is, we bring the 15 from the left to the right, and we substitute x equals 1,000 here, and we get 15 plus 7.5 equals $22.5, which is exactly the same. So it doesn't really matter, once you've got the point slope form, which ordered pair you use. In the first case, we use this. In the second case, we use this into the point slope form, but it still gives us, will still give us exactly the same equation. In a certain city, the taxi fare for a 6-kilometer trip is $13 and $20 for a 10-kilometer trip. Express the fare, the cost of the fare, y, in a linear equation with the distance of the trip. So we need an equation that says y equals something, and on the right-hand side we'll have x. What is the start charge of the taxi fare? What is the taxi fare for a 25-kilometer trip? So first of all, we're going to use this as an ordered pair, 6, 13, because I want y should be the $13, okay? And x has to be the distance. So we use 6, 13 as one of our ordered pairs, and we use 10, 20 as my second ordered pair. It must always be x, y. So I've got one ordered pair, I've got a second ordered pair. The difference in the y's, 20 minus 13 over 10 minus 6. 20 minus 13, my difference in my y's, over 10 minus 6. 20 minus 13 is 7. 10 minus 6 is 4. I get a 1.75. Now, I use the point slope form. I know what m is. M is 1.75, so I substitute it over here. My y1 is 13, so I put this over here, and I put my x1 right here, minus 6. Okay, so the start charge is the charge that what goes on the meter even before you've gone any distance. So when you go into a taxi, you might have, when the meter starts, there's an immediate charge of, let's say, $4.25. It will depend what city you're in, etc., etc. But the start charge is just to get in the taxi and when the meter starts running. So the distance is really 0 because you haven't gone very far. So now what I'm going to do is take this equation here and substitute 0 for x. So I get 13. I've transposed the 13 from the left to the right. That's all we've done. That's why this is over here. And now I'm going to substitute 0. I get minus 6. 13 plus 175 times minus 6 comes 13 minus 10.5, which leaves me with 2.5. In other words, the start charge here is $2.50. This meter, when it starts, when it's turned on, starts at $2.50. So that means it's your start charge. Now we can check this by substituting the other ordered pair instead of using the 1020, which we did over here. Okay, so instead of using the 613, which we used over here, we can use the 1020 into the equation for our x1 and our y1. So y minus 20 equals m, which is still 1.75, x minus x1, which is 10. x1 in this case is 10, y1 is 20. And if we use this equation and we set x to 0, as we did up here, we come out that y equals 20 plus 1.75, 0 minus 10, because we're replacing the x with the 0. So it's 20 minus 17.5 is 2.5. So we get exactly the same value as the start charge. This equation here, right here, and this one are the same. It's just that we've used a different set of ordered pairs. In the third part of the problem, let's read it. What is the taxi fare for a 25-kilometer trip? So here we know that x equals 25 because x is the distance. We substitute it into this equation here. For x, we put 25. Then we have 20 plus, this is 15 times 1.75 gives us 26.25. The total cost is 46.25. Now, if I take the other formula that I derived and substitute 25-kilometer trip in here, then we get y equals 13 plus 1.75x minus 6. Let's go back up here, and you can see what we're doing is substituting in this formula right here, the very first one. And we get 13 plus 1.75x is 25. And this will be 19. 19 times 1.75 gives us 33.25. When we add 13 to 33.25, we get 46.25, which is the same as we got over here. So whether we use, let's recapitulate here, we came out with a basic formula, and we knew that m was 1.75. We used the first ordered pairs to derive the formula. We got a formula. We got the same formula with using 1020, and we got the same start charge, and we got the same cost of a 25-kilometer trip.